Okay. All right. Let's take a look at question 3. In question 3, we're given 4 relations here: a table, a graph, an equation, and a map. The question is, which relation is not a function? So in this problem, we're being assessed on our ability to identify what a function is and what a function is not. So depending on the presentation that you're given, that will determine the approach that you will use to ascertain if a relation is a function or not. Okay. All right. The first one, we have a table. Whenever you're given a table of values, what you are looking for is repetition in the x's. Okay. So let's write that down. Repetition in the x's. If there are no repetition in the x's, then it is a function. If there are any repetition in the x's, then that's not a function. Okay, so let's just be more specific. No repetitions in the x's. All right, so look at all the x's. Are there any repetitions? There are no repetitions in the x's. So what does that tell us? This relation is a function. Why is it a function? If there are no repetitions in the x's, that means that every input is being assigned to a maximum of one output. Okay? If you have one input going to more than one output, which results in a repetition in the x's, that relation is not a function. Okay? So in this problem, we're looking for what is not. So what is should be eliminated. Number 1 is gone. Okay, number 3, we have a graph. Whenever you're given a graph, you're looking for a graph that passes any graph that passes the vertical line test, the VLT. Okay, vertical line test. So does this graph pass the vertical line test? Well, let's see. All we just have to do is draw a vertical line and sweep it across the entire domain and see if we have an intersection that's more than one. So if I draw a vertical line and sweep it past the entire domain, we can see that all the intersections are exactly 1. And since this is an absolute value function, we expect the same pattern to repeat itself forever. All right? So since the maximum number of intersections is 1 for every point in the domain of this function, what does that tell us? It tells us that this relation right here is the graph of a function. So it basically passes the vertical line test. Okay, so let me highlight my vertical line. So we have one there. There's another one. So just to illustrate, what I'm trying to show you here is that these vertical lines are intersecting the graph at exactly 1 point. All the vertical lines do that. Okay, so what this is showing us visually is that every input which go along from the vertical line from the x to the graph is assigned to exactly 1 output. All right, so this passes the vertical line test. What does that mean? It means that this relation is a function. Now let me show you an example of a graph that fails the vertical line test. Let's say you have something like this. Do you see why this fails the vertical line test? This relation is not the graph of a function, because if I draw a vertical line right here, what do you have? You have 3 intersections. So this is good, but we have another intersection and another intersection. What this is telling us is that one input will be assigned to 3 different outputs, which is not what a function is. So this fails the vertical line test, hence it is not a function. Okay, this one is a little bit abstract, but hopefully you get the gist. So fails the VLT, not a function. Alright, this is just a side example. Now, let's shift our gears to option 2. Option 2, we have an equation. Now, whenever you're given an algebraic equation or function and you're asked if it's a function or not, all you do is you look at the powers of your dependent variable, namely the y's. Okay. Now, in this particular case, this y has a power of 1. If the power of the y is odd, then it is a function. If the power of the y is even or absolute value, or you have absolute value around the y, then it is not a function. Okay, so let's write down our observation. Y has an odd power, which is good, and no absolute value brackets. Okay, if it had an even power or an absolute value bracket, one of the two, then it is not a function. So since y has an odd power, no absolute value brackets, that means it is a function. That's a pass. Okay. All right. Let me show you an example of functions that are not absolute, that are not relations in equation form that are not functions. For example, you have y to the 100 plus x equals 4. This is not a function because the power of y is even. Or if you have x equals the absolute value of y plus 3, let me write that again. X equals the absolute value of y plus 3. This is not a function because the y, the dependent variable, has an absolute value. And then this is not a function because the y has an even exponent. Okay, so these two are not functions. But this is a function because the power of y is 1, and 1 is what? Odd. Okay? All right, number 4. We have a map here. So this one is a little bit complicated to do. You could visualize it, but if you just take a look at what's going on, you want to ask yourself, is every input going to a maximum of one output? That's what you're asking. 1 is going to exactly A, which is good. 2 is going to A and B, which is horrific. That is a no-no. So since this 2 is going to 2 outputs, that automatically tells you that this relation is not a function. All right. Another way to approach this is just to use your mappings, convert it to ordered pairs. Okay, so here we have 1 goes to A, and then 2 goes to A, and then 2 again goes to B, and then 3 goes to C. So if you look at your ordered pairs here, you see that we have a repetition in the x's, and that's a violation of a condition to be a function. All right, so let's write down what we observe here. The input 2 is assigned to more than one output. Is assigned to more than one, it doesn't matter if it's 2, 3, 4, 5, 6, is automatically not a function. Okay, so more than one output, and that tells us that it is not a function. Hence, this is the correct answer that we're looking for. All right, the other ones are functions, so we don't want to select them. Answer to question number 3 is option number 4. Now, out of these 4 options, which one is the easiest for you? Which relation is the easiest for you to ascertain if it is a function or not? We'd like to know. So let us know what your selection is. Put it in the comment section below and tell us why is that particular representation the easiest for you to determine if a relation is a function.